multiplying binomials. So first of all, this is good to recall a couple of our definitions from grade 9. What is a binomial? Something with two terms. And if you multiply a binomial by another binomial, so if I'm multiplying 3x plus 2 times x plus 1, I have already shown you with colors this. So this is equal to, if I multiply the 3x by the x, I would get 3x squared. If I change this one, 3x times the 1, I would get plus 3x. Color coding as I go. What haven't I multiplied? Plus 2x. And finally, plus 2. And then since we have some like terms, we end up with 3x squared. These two are like terms, plus 5x plus 2. So I showed you that with colors. In English, we give this a special name. We give this the name, oops, got to color code it right. And then I'm going to see if you can figure out why we call this foil. So we call this foil. I'm going to write the F in green to match up with the arrow, the O in blue, the I in red, and the L in purple. Okay? How does that help you remember? What do you think? First, okay, you get one. You're right. The green stands for the first ones. You multiply the first ones together. You're going to do the O? Outside for the O. Who wants to try? Inside for the I. And last for the L. So in English, we have this acronym FOIL to help us remember that we multiply the first ones, the outside ones, the insides, and the last ones. Basically, everything gets multiplied by everything. That's what our arrows show in the end. And when we write our final answer, so our final answer for this is 3x squared plus 5x plus 2. Why did I write the 5x in black? I applied the like term, so it's no longer, it's kind of like this is the outside and the inside got combined, right? But the last one still showed up. The first one still shows up. But the other two get combined. This is the most typical method that we're going to use for multiplying binomials. There are other ways of multiplying binomials. Okay? Oh, we're going to have fun today. The chart method. So we're still going to multiply the same numbers that we had before, which is 3x plus 2. I'll write it up here. 3x plus 2 multiplied by x plus 1. The chart method looks like this. We make a chart. I really like the chart method too. On one part of the chart, we choose our first binomial. And instead of going 3x plus 2, we just separate the 3x and the 2. And on the other part, we write x and 1 and separate them. And we make a multiplication chart. If you filled in all the boxes, what happens when you multiply x times 3x? You get 3x squared. What happens when you multiply the 3x times the 1? You get 3x. What happens when you multiply the 2 times the x? You get 2x. And what happens when you multiply the 1 times the 2? You get 2. If you write out your answer then, are any of these like terms? Yes, the 3x plus the 2x is 5x. And it's the same thing. Okay? And the final method that we have is with actual algae tiles. So again, we're going to multiply 3x plus 2 times x plus 1. And the algae tiles method is almost identical to the chart method, except instead of writing 3x plus 2, you take algae tiles 1, 2, 3, and you take 1 tiles, that would be 3x plus 2. And the same thing along the other side, except we'll have to turn them. We're going to show x plus 1. So it's kind of like the chart, except you line up your 3x plus 2 on one axis and your x plus 1 on the other axis, and you draw dotted lines and say, what would I need to fill in these spaces? In here, I would need an x squared. I would need an x squared here, and I would need an x squared there to fill in those spaces. This one I'll need an x to fill in. This one I'll need an x to fill in. Here I'll need an x to fill in. Here I'll need an x to fill in. Here I'll need an x to fill in. And here I'll need a 1. So once that whole rectangle is filled in, what do I have? I have 3x squareds, 1, 2, 3, 4, 5 x's plus 2. Yes? Sometimes there'll be a question that shows it to see if you understand how it works. Sometimes it might ask, can you show it with algae tiles? Okay. Now, the algae tiles and the chart method are almost identical, just one has you drawing a lot more than the other. Okay. But both of these, they're very helpful because these ones are based on the idea of area. And so what I want to show you next is that you could use any of these three methods to help you with multiplication of numbers that maybe you're not good at multiplying by. Okay? How many people know their 17 times table? 17 times table up to 29? No. Okay, good. Perfect. Well, let's do 17 times 29 using our first method. How would I use multiplying binomials to help me do 17 times 29? I want to do 17 times 29, but instead I write it as 10 plus 7 and 20 plus 9. Question, can you do, oh, I'll keep my colors right, 10 times 20 easily? That's 200. Outside is blue. Can you do 10 times 9? Plus 90. Good. Inside, 7 times 20. Plus 140. Great. Last ones, 7 times 9. Plus 63. Adding these all together, $493. Nice. So you could multiply 17 times 29 using FOIL. And the hardest multiplication you had there, what's harder, 7 times 20 or 7 times 9? I don't know. Maybe they're about the same. If you know your times table up to 10, you can now multiply 17 times 20 using FOIL. And what's really neat is some of the algebra things that we learn, we can apply to numbers. Okay? 17 times 29 with the chart method. 17 times 29, you could have a rectangle that was 29 by 17. And I'll write the 29 and the 17 here. But instead of writing it a rectangle as 29 times 17 and finding out how many squares there. I'm going to break it up and make this part 20 and this part 9, this part 10, and this part 7. And I'll draw my chart. What's the area of this rectangle? Well, now that's easy to figure out. It's 400. The area of this part is 90. The area of this part is 140, and the area of this part is 63. If we add them all up, we get the same answer as before. Yes? Yeah, 200. 10 times 20. There we go. Perfect. So the chart method is really getting you to think about areas. The algae tile method is the same as the chart method, actually using sizes of shapes to help you figure it out. So this is the same idea as the algebra tiles method. Which method do we use the most? Probably the foil method, because it's the quickest and takes the least amount of space. But some people really like the chart method as well. So here, now, it might be at the beginning that you always draw your arrows, which is great. I'm going to color code them like I have been. First, outside, inside, last, yes. Yep. You could, yes. So the question was, could we do that with, so if I have 327 times 29. Now, foil doesn't work out perfectly here because we would have to go first outside, okay? Then inside 1 and inside 2 and then another inside and another inside. You'd have a lot more arrows, but all the arrows would still be there. So it's kind of like foil, okay? But it will work the same way. And same thing with your chart. You can make your chart, just break it up into bigger, and you'd have more little areas that you'd fill out. Okay, so for this one, if I multiply my green ones, x times a negative 2x, negative 2x squared. My blue one, x times 1 plus x. My red one, negative 1 times negative 2, x plus 2x, and my purple one, negative 1. So in the end, when I combine my like terms, my green one stays the same, my red and my blue one will get combined, and my purple one stays the same. I would like you to try the next 1, 2, 3. I want you to try the next 3. I'll do these so you can see how you did. There's the first one. How'd you do? There's a question above this one that I missed. Was it this one?
It was find the product of x plus 5, x plus 4.
Okay, you must. I will just add that one in then. So before this one was x plus 5 times x plus 4?
Yeah.
Okay. And is that what you got? Excellent. Eventually, what I'd like you to be able to do is do that all in your head and just write the answer down. Okay? Like eventually, grade 11, grade 12. Some teachers want you to show all your work all the time. But I don't think the mental math is that hard. Okay? Because what do you know for sure? You know that the first ones stay the same. Right? So you know that that's going to be x squared. You know that the purple one's going to stay 20. And it's just a matter of being able to do that outside and inside in one step. But until then, please write it out. And if you like to color code things, that works really, really well. So we've done that one, that one. Is this the next one? Same colors. Two x squared minus 8x plus 3x minus 12 equals 2x squared minus 5x minus 12. How is foiling going? Not bad? Okay. What does an exponent mean? What does that little 2 mean? How many times you times that number by itself? So the number one mistake that, because they always, well, I'm not going to say always, but 99% of grade 10 exams have this on there. Because what students want to do is just square the x and just square the 7. But what you said about the definition of the exponent is right. It means repeat multiplication. So when I have x minus 7 squared, it means x minus 7 is multiplied by itself twice. And if I have written it this way, well, everything needs to get, uh-oh, wrong first color. Whew, that was close. Everything needs to get multiplied all the way through. And so this would equal x squared minus 7x minus 7x again, minus 7 times minus 7 plus 49. And careful with that minus 7x and minus 7x that doesn't become 0, because that would become negative 14. Couple more to try on your own. Again, my same color coding. There's the first one. How'd you do? Good. And here's the second one. And how do you do with the last one? Good. A little bit harder with the adding and subtracting the negatives there, but not too bad. All right, so here is stuff to work on.